I'm doing wear resistance tests for 12 different knives, different metal, and I will draw a cut to the sand because the sand will eliminate the give consistency in terms of how the sand will impact the edge and independent of the geometry. Because you draw, so I stick the blade down and draw across, and after every 10 draw I will test against slice newsprint. Let's start out with the box cutter as a reference point. You can cut no problem. Insert it in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Test again. It failed. Not make it. So, okay, now I will just go through. So it took a long time for me to sharpen those 12 knives, but I'm going to do this quickly. This is the Mora Carbon. I don't know exactly what number it is, but we'll do draw 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have showed you that it cut newsprint before, but it probably still cut. It's haltingly now. All fail. Okay, Mora Carbon is done. Pretty much got somewhere about 10. Now you have, this is the Spyderco stretch. The steel is ZDP 189, and we'll see. Okay, here you go. It has a little microchip, but you can see overall it cuts smoothly. But when it cuts sand, every tear will tear, but we'll ignore a little microchip in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still cut. So let's call the ZDP stretch can handle call it 20. Now we have a lot of knife to go through, and now this is CPM M4. Hardness is like 65, and you can see how smooth it is cutting the newsprint. And we'll go through the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 5, 6, 7, 8, 9, 10. I'm pressed for 10, so anyway, it's still cut. Overall, I mean, there are a little hiccup, it not matter. I think overall the donut is about 30. Look like it in about 40. CPM 154. Smooth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still going there. 2, 3, 5, 7, 9, 10. There you go. It fell. If I count correctly, I think it was either 30 or 40, so I just miscount. Too much of a hurry. I think it was also a 40. Alright, we conduct to the next one. This is the 14C28N. And, oh yeah, let's test the paper. One. Yeah. Actually, halting lead. Let the just make sure it's completely dead. Well, it's still halting lead though. Refuse to die. At 30 already. Yeah. Okay, it's about 30. Benchmade 940 S30V. Still going okay. Die 20. Ah, I got sand in my lock. Yeah. Ah, it's 20. 15 and 20 carbon. Sharp. What's going on here? I think it's dead. And I could do more one at a time, but that too long. And this was from, this is 52-100. Haltingly. Still haltingly. Look like we alright. That's 20. Ready? Die. That will give us about 40. K390. Very high alloy, this not tan. Not 40. I want to cut, huh? Let's see. Well, it's still trying to hang on. This part of it's still good. So I would give another 10 more. It's 50 of it. Okay, say 60. I really let it make sure it die consistently instead of one spot got cut. So that is the 60, which is much better than CPM M4, and this is 1084 steel. Smooth. I say they got 10. S35VN. Clean it, make sure it be fair here. Okay, it's still okay. I think I moved the thing too far over there. Ah, 20. Well, we got the last one. This is K110, which is the same thing as D2. And I have a little microchip, that's okay, but you can see it cut fine. We don't care about microchips. No, they're not a little dried up. Make sure there are only 10 in the die. Yeah, consistently you get caught. It's not just like one spot that we can overlook. This one is smooth, so I probably give it another 10. Okay, so we have about 20. So the two most high alloy one is a K390, which have a lot of, they have 9% of vanadium and, no, 9%, yeah, and then 1% of tungsten. And they have some other thing, cobalt in there. It got the highest score, 60. While the other one, CBM M4, is also very high alloy, which is 5% vanadium and 4% tungsten there. It should be also very good. It seems like it actually it's okay. I think this there a little microchip in here. Let me try to make sure. Okay, it's about to die. So that add another 10 to it. Okay, anyway, so this you give it another 5 more, 10 more, yet to be. So it will play like second. You get 50 cut to the sand. So you can see, summarize up, you have a lot of these carbon knives, these low alloy. 1084, the more, they got about 10 cut. And surprised me is the ZDP 189, which have a lot of chromium carbide, but they only managed to get 20 cut. And versus something like CPM 154. It's, well, not as high amount of carbide, chromium carbide, and the other, iron carbide, the ZDP 189, but they got like 40. So, and the sand seems to be fair for everything. And so, because the edge, when they go through, they get impact with the sand. And so we'll just dull it. I mean, this one, sand, some sort of silicate and some other thing in there. And the dulling is going to be affect all mellow and have the, some abrasion or abrading the apex away. And just like this one, also carbon here, and the 15 and 20, they are only 10. What surprise is the 52-100 steel got 40. And let me clean it and give it a last shot before we call this video is done. It's hot and late if you played it, good place. But anyway, as you can see, this way I can test the wear resistance of the knife without worrying about how much effort and whether the toughness have a lot to do with it, or the strength, how hard it is, have a lot to do with it. This just wear. This been abrased away from by the sand. Anyway, from this test conducted, when I conducted the other two tests, one was cut in palm front and the other one cut in rope. But the other one being, I say, side effect, which is you end up cutting the cutting board. And so it not really reflect about wear resistance, but it's more endurance, how long an edge can last against impact. In this case, how long the edge can last against wear. Anyway, thank you very much for watching.